Students, now I'm going to explain all the 5 marks problems in determinants. In the previous videos I uploaded inverse trigonometric functions 1 plus 2, matrices 1 mark, 3 mark and 5 marks. Determinants I uploaded 1 mark and 2 marks. Now I'm going to do 5 marks. After I will upload 4 marks. See this problem, solve 2x plus 5y is equal to 1, 3x plus 2y is equal to 7 by matrix method. They are asking by matrix method. We can consider let A is equal to matrix 2, 5, 3, 2. We can consider matrix A is equal to 3, 5, 2. X is equal to xy. I can write x is B is equal to 1, 7, 1, 7. So from this I can write Ax is equal to B, right? So just I written the equations like this. So before solving the problem, what I will do now? Here I will find here. You can see operating A, this one, Ax, B I have written. A is equal to 2, 5, 3, 2, x is equal to xy, unknowns, and B is equal to 1, 7. So you can find that A value. If I find that A value, determinant of 2, 5, 3, 2, you can find that A value. It will come 4 minus 15 minus 11. So not equal to 0, right? So definitely A inverse you can find here. Because when you are solving the problem, always you will write Ax is equal to B, right? Always I prefer I can write this Ax is equal to B, right? Because I will write Ax is equal to B. So here I will get x is equal to, this implies x is equal to A inverse into B. So we want A inverse, right? But for 2 by 2 easily you can get A inverse. A inverse equal to 1 by A into dAd minus 11, that A. This is that A minus 11. Correct. 1 by det and adjoint A. A inverse means 1 by det and adjoint A. 1 by det and adjoint A. How to get adjoint A? Just interchange these two. Change the sign of these two. Minus 5, minus 3 for 2 by 2. Interchange these two. Right. Because luckily we have both are same. So that we will get the same thing. 2, 2, minus 5, minus 3. If I this one, this is A inverse. I want x equal to A inverse B. So A inverse this one. Minus 1 by 11, 2 minus 5, minus 3, 2. Into you will get 1, 7. You get minus 1 by 11. Just simplify. This first row with first column. Be careful here. This is 2 by 2. So you will get this is 2 by 1. Again it comes 2 by 1, right? It will come 2 by 1. Correct. You can check the first row with first column. You will get 2. Correct. You will get 2. This is minus 35, right? And this one minus 3. Minus 3 plus 14. It will come right. You can simplify minus 33. It will come right. Minus 1 by 11. If we simplify this one, I will write here. You will get minus 1 by 11 minus 33, and you will get minus 3 plus 14, 11. So you divide this, you will get 3, and this is minus 1. Correct. After this I have done. After this you can go here. Minus 1 by 11 minus 33, 11. You divide with 11, 3 and minus 1. So therefore finally we got x is equal to 3, y is equal to minus 1. So this is your answer, right? X equal to 3, y equal to minus 1. After solving this x equal to 3, y equal to minus 1, we have got the answer right. You can also verify 2, 3, 6, 6 minus 5 equal to 1. Even if you check 3 into 3, 9 minus 2, 7, it satisfies. So this is your exact answer. Now, see, after learning this, you solve this problem. Immediately you solve these two problems, you will get an idea how to solve this. First look into this problem, then you solve this one. But remember, when I am finding that A, so like A, this is 2 into 2 minus 3 into 5. So when I am finding A inverse, 1 by det and adjoint A, 1 by det A, this is the value, adjoint A, interchange these two elements, change the sign of these two elements, it gives adjoint of 2 by 2 matrix. Then you can simplify. You multiply this, you will get this one. So like this you solve these two problems, then you will be thorough with this model. Now I will do with the 3 equations. Now see this problem. Now I will explain with the 3 equations. Just we have done 2 equations. I will explain now with the three equations how to solve it. This is the most important model by matrix method. Definitely 5 marks they are asking this one. We can consider let A is equal to, you can write 3 minus 2 3, and I can write it 2 1 minus 1 4 minus 3 and 2. This is given matrix A. I can write this one. A, this one I can write x is equal to, I can write x y z, and b is equal to three variables, right? 8 1 4 8 1 4. From the given matrix we can write this. Now I can find det A here. When I am finding det A here, determinant, you can write 3 into, leave this row in this column. You will get 2 minus 3. I can write minus of minus plus 2. Just minus, because you get plus minus plus to expand. To expand this minus plus 2, leave this row in this column. You get 2 2's 4 plus 4. You can find plus 3 into, leave this row in this column. 2 into the minus 6 minus 4. It will come this one minus 3, and this is a 16 and minus 30. So you get minus 17, which is not equal to 0. Correct? Then I can find A inverse. So how to find A inverse? A inverse is equal to 1 by det A into adjoint A. So adjoint A is required, right? We have adjoint A is required. 1 by adjoint A is required. To find adjoint A, to find adjoint A, you can see to find adjoint A, I can write adjoint A is equal to, I can write the matrix whole transpose. You can see here transpose of the cofactor matrix. Write every element of cofactor of 3. You write cofactor of 3, you write determinant of this. You can write cofactor of 3. Leave this row in this column. 1 minus 1 minus 3 2, and you can write, leave this row and this column. 2 minus 1 4 2, 2 minus 1 4 2, and here if I write, leave this row in this column. 2 1 4 minus 3, 2 1 4 minus 3. But here you can see this is A1 1, so plus A1 2. Some of the suffix is odd number, means negative. This is minus plus, plus minus plus, cofactors. Without plus or minus, if you write, that will be minor. Multiply with corresponding sign. Now you can see here, coming to here, this is A21. A21 position, 2 plus 1 3, odd number. So this one minus, again determinant of, leave this row and this column, minus 2 3, minus 3 2, minus plus, because A22, 2 plus 2 4, A22. Leave this row in this column, 3 3 4 2. You get 3 3 4 2, and here minus, because this is A23. So leave this row in this column, 3 minus 2 4 minus 3, 3 minus 2 4 minus 3. Coming to here now, you can see in this one, I can write same thing, A31. This is position of A31. A31. So third row, first column. Some of the suffix will be 4, positive. Leave this row in this column. Minus 2 3, 1 minus 1. Plus right. Coming to here, this is negative, right? Because A3, A31, A32. Leave this row in this column. 3 3 2 minus 1. 3 3 2 minus 1, right? Now the last one. A3, A31, 3 2, A33. 3 plus 3 6, even number, positive, right? This will be positive. Leave this row in this column. Leave this row in this column. 3 minus 2 2 1. 3 minus 2 2 1, right? You will get like this. Now you can check here. When I am finding adjoint A, I can write determinant 2. This will be 2. I can write minus 3 and minus of 4 plus 4. This is, I can write minus 6 minus 4 minus of just 2 by 2 determinant. I can simplify minus 4 and this one minus 9 plus 9, and this one 6 minus 12, and here minus of, this is minus 9 plus 8. Now here coming to last one here, 2 minus 3, this one minus of minus 3 plus 6, and this one 3 plus 4. Transpose of this. Think about transpose of that. Right? When I written, I should simplify here. When I written, what the matrix will get? You get minus 1, this one minus 8, this is minus 10, and here 5 minus 5, minus 6, and this is minus 1, you will get, right? This is minus 1, 3 minus 3, you will get this one 7. So this is the matrix you will get, right? Just be careful, I have written minus, you will get minus 1, minus 8, minus 10. We got it right. Minus 10. Minus 5, minus 6, 1. Correct. Minus 1, you will get, you can verify this. Minus 1. I can also verify this one. I got it here, right. Minus 3 plus. Why? Because this second position here. This will leave this one, this one. 3, 3, 2, minus 1. So minus 3, you will get minus 6. So be careful, this is minus 6. Minus 3, minus 2 is 6. You will get 9, it will be 9. So this element will be 9, you will get. 9 minus 1, 9, 7 it will come, right. Minus 1, 9, 7. Correct, minus 1, 9, 7 you got. This is the adjoint of the matrix. This is the adjoint of the matrix. Now because I want to find A inverse. Correct. Now I will simplify here. What I will do now? After finding this adjoint, I am going to simplify now. I can write here. So we got the transpose of this. Be careful, transpose of this. Transpose of this means what it comes transpose of this if you write, the transpose will come minus 1, minus 8, minus 10, minus 5, minus 6, minus 4, minus 6, 1. Because first row with first column, second row with the second column, third row with the third column. Minus 1, 9, 7. So this is adjoint of the given matrix, right? That will be adjoint of the given matrix. We got it right. Minus 10, 1, 7. Adjoint of the given matrix. Because you should know adjoint of the given matrix to simplify the problem. After that, after finding this, I can write here A inverse is equal to 1 by, because we have taken det A. Det A we got minus 17, right? Minus 17 into, I can write minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1, 7. This is A inverse, right? Now I will write Ax is equal to B. Implies x is equal to A inverse into B. I can do A inverse is this minus 1 by 17. Minus 1, minus 5, minus 1. The matrix I can write here. Of writing this, I can write x is equal to A inverse minus 1 by 17. The matrix minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1, 7 into B. What is B here? 8, 1, 4. This is B, right? But in this side we know x, y, z. Column matrix x, y, z. I can multiply this. Minus 1 by 17. This is 3 by 3. So this is 3 by 1. Multiply, it gives 3 by 1 again. 3 by first row with first column. You will get minus 8, minus 5, minus 4, minus 64. You will get minus 6 plus 36. Now this is minus 80. I can write plus 1, plus 28. 28. I am going to simplify this value. Just after finding this value, I am going to simplify. You can see here. This side x means x, y, z. Correct. This is x, y, z. I written this is x, y, z, which is equal, correct? X, y, z. I written minus 1 by 17. You can simplify. This is minus 17. Minus 17. When you are simplifying, you will get. You can add this one. Minus 64 plus 36. Minus 6. You will get minus 70 plus 36. It gives minus 34. Correct. Now you can see here. Minus 80 plus 29. Minus 80 plus 29. It will come this one 51, right? Minus 51. You multiply with this. It comes 1, 2, 3. Comparing both sides, I can write x is equal to 1, y is equal to 2, z is equal to 3. I got x equal to 1, y equal to z equal to 3. After finding the value, you can substitute here to verify whether you got it perfectly or your answer is perfect or not. You can verify, substitute these values in this, you can verify, definitely you can verify. 3 minus 4 minus 1 plus 9, 8. It satisfies. Definitely. This will be your answer. Now we will solve the next problem. Now this problem is similar to the previous one. They are given three equations by matrix method. I can define what is I can write. Let A is equal to the matrix 2, 3. I can write 3. For the second equation 1, minus 2, 1. Third equation 3, minus 1, minus 2, right? This is A. I have taken A here. I can write x is equal to x, y, z, and b is equal to 5 minus 4, 3. 5 minus 4, 3. From the equation you can write A, x, b. Now I can write here, I will find det A. When I am finding det A, 2 into, leave this row and this column, you will get 4 plus 1 minus 3 into minus 3, leave this row and this column, get minus 2 minus 3 plus 3 into, leave this row and this column, minus 1 plus 6. I will explain again. When you are finding determinant, 2 into, leave this row and this column, determinant of this into this, minus this into this, minus 3 into, because when you are expanding determinant, always use plus, right? Minus 3 into, leave this row in this column, minus 2 minus 3 plus 3 into minus 1 plus 6. You simplify this. 2 into 5 minus 3 into minus 5 plus 3 into 5. This will be 10, 15 plus 15. It will come here 40, right? Which is not equal to 0. Then I can find A inverse. What is A inverse? I can write. You can think A inverse is equal to 1 by det A into, I can write adjoint A, right? Adjoint A. Now I am going to find adjoint A. Just remember, det A value, remember we got 40. I am going to find adjoint A. Adjoint is required to find A inverse. So now you can see, I can see that I'm writing this, I will write adjoint A now. I will find adjoint. You can see how to find adjoint when I am writing adjoint A. So this one I will write the matrix transpose of this transpose of the cofactor matrix. So we write 9 determinants. You can write, because you can use the concept of like this. Write 9 determinants. Correct? Plus, minus, plus, alternative, right? Here plus means minus, minus means plus, plus means minus, plus, minus, plus. Now to find adjoint, leave this row and this column. Here you will get minus 2, 1, minus 1, minus 2. Coming here, leave this row and this column. 1, 1, 3, minus 2. This one, leave this row and this column. 1, minus 2, 3, minus 1. Coming to here, leave this row and this column. 3, 3, minus 1, minus 2. Here, leave this row and this column. 2, 3, 3, minus 2. Then here, leave this row and this column. 2, 3, 3, minus 1. Correct. Again coming to here. Leave this row and this column. 3, 3 and minus 2, 1. Come here. This one and this. 2, 3, 1, 1. The last one, leave this row and this column. 2, 3, 1, minus 2. Correct. I am finding a joint now. When I am finding a joint, you can see here. So I can write this into this. 4 plus 1, it will be 5, right? This one minus of. So when I written minus of this, minus 2, minus 3. Minus 2, minus 3. 5, it will be 5, you get 5, 1 again, right? This one, minus 1 plus 6, correct? Just you multiply minus 1 plus 6. If you want to correct one more step, you can write minus 1 plus 6. Minus 1 plus 6, minus 1 plus 6. You get 5. This one again, minus of this is minus 6 plus 3. Minus 6 plus 3. Correct. You can write clear all the steps. If you want, I can write the steps neatly. I can write. I can find adjoint matrix. Okay, this is minus 2, 4 plus 1. Minus of minus 2, minus 3. I can write this is minus 1. Minus 6 means plus 6. Correct. Just AD minus BC. Now this one, minus of minus 6 plus 3. Correct. This one I can write minus 4 minus 9. This one minus of cross multiplication minus 2 minus 9. Correct. You can see this one 3 plus 6 minus of 2 into 1 2 minus 3 into 1 3. This one again minus 4 minus 3. Transpose of this, transpose of that. When I have written this, I can write here. This is a matrix 5. This is also 5. Here also we got 5. Minus 3 plus 3. I got this is minus 13. And this is 11. 9. And this is minus plus 1. And minus 7. Transpose of this. See, when I have written transpose of this first column, 5, 5, 5, and this is also 5, and 3, minus 13, 11, 9, 1, minus 7. Write the transpose of that. First row with first column, second row with second column, third row with third column. We got transpose, right? Now I can use the verb. Just remember the transpose. Now we will solve the problem. After finding the transpose, I can use Ax is equal to B. X is equal to A inverse into B. Then X is equal to A inverse 1 by 40 into the matrix trans. Because A inverse is 1 by adjoint here, right? 1 by adjoint A. Adjoint I have written here 5, 3, 9. 5 minus 13 1 5 11 minus 7 into B. What is B? We have 5 minus 4 3, right? This I am going to simplify. 1 by 40. This is 3 by 3. This is 3 by 1. So again the product comes 3 by 1 only, right? First with first column. So 25. This one minus 12 plus 27, right? This one I can write 25 plus 52, 52 plus 3. This one 25 minus 44 minus 21, minus 21. I am going to simplify this, right? So I can write a 1 by 40. 1 by 40. This one 25 minus, you can see here 25 minus 12. You will get this one 25 minus 12 means this one minus 13. Plus 13 27. 27 13 40. You get 40. This one you can check here. This one 25, this is 55. 25, 55, 80. And this one 25 minus 44 minus 21. You can check here 25 minus 44. Correct. You can simplify this one. Or you can see 25 minus 63. 25 minus 63 means you can check that you are getting here. This is 44 written. If 25 minus 44, you will get minus 21, right? This is the value we have. This is totally have 65. You get minus 40. So it comes 1, 2, minus 1. We got this one. X, Y, Z equal to 1, 2, minus 1. X is equal to 1. Y is equal to 2. Z is equal to minus 1. Now you can verify. Substitute this 2 into 1. 3 into 2, 6 plus 2, 8. 8 minus 3, 5. It satisfies. You can substitute, you can verify that. So this is the required answer. And now I will solve one more problem. Now, like previous problem method only, I am going to do one more problem now because practice is important. Now if I take this one again, I can consider A is equal to 1 minus 1, 1, 2, 1 minus 3 and 1, 1, 1. Again, X is equal to X, Y, Z. X, Y, Z, these are the variables X, Y, Z. B is equal to 402. 402. Then I should find det A. When I'm finding det A, I can write this one. Just I can expand 1 into. Because determinant you know how to find it. Det A 1 into, leave this row in this column. 1 plus 3. Minus of minus plus 1 into, leave this row in this column. 2 plus 3 plus 1 into, leave this row in this column. Determinant of this 2 minus 1. You will get this is 4 plus 5. This is 1. It comes 10. This is not equal to 0, right? I can find here that A I can find here. At the same time, you can also think A inverse. A inverse is equal to 1 by det A into adjoint A. 1 by det A into adjoint A. I'm going to find adjoint A now. If I find adjoint A, then we can solve the problem easily, right? We got that not equal to 0. A 1 by det A into adjoint A. So when I am finding adjoint, you can check that now. When I am finding adjoint A, when they are asking adjoint A, I can write transpose of this, right? You will get 3 by 3 matrix adjoint A. This is written adjoint A. This is equal to, I can write 9 determinants, right? You can consider 9 determinants. Plus minus plus. Minus plus minus alternative. Get plus minus plus. For plus minus plus minus plus minus. Minus you get, this is you get minus, right? Minus, sorry, this is plus minus plus. Now you can check here. When I am doing this 3 by 2 determinant, here you can see 2 by 2. I am writing cofactors here. That's the reason I have to multiply with corresponding sign. So you leave this one, leave this and this 1 minus 3, 1, 1. And minus of, if we take this, leave this row in this column. 2 minus 3, 1, 1. This one, third, leave this in 2, 1, 1, 1. I can write 2, 1, 1, 1. Coming to this, minus of, I am taking this one, minus of, leave this row in this column. Minus 1, 1, minus 1, 1, again 1, 1. And here, leave this row in this column. All ones, so you will get 1, 1, 1, 1. This, leave this row in this column. 1 minus 1, 1 minus 1, 1, 1. Coming to here, this one, leave this row in this column. Minus 1, 1. Minus 1, 1, 1 minus 3. Leave, again, second, leave this row in this column. 1 1 2 minus 3, 1 1 2 minus 3, right. 1 1 2 minus 3, 1 1 will get, leave this one, this called 1 1 2 minus 3, leave this and this, 1 minus 1 2, 1 minus 1 2 1, 1 minus 1 2 1. Now I will simplify this, right. I can write adjoint A transpose of this. You can see this is 1 plus 3, correct. I can write expansion, I can write 1 plus 3 minus of, will write 2 plus 3, that one 2 minus 1, correct. Now this one, you can see the second one, second row. In second row I can write this one minus 1 and plus 1 minus 1. This is minus of, outside with minus of, right. Be careful the symbols, minus, this is minus of minus 1 minus 1. This is 1 minus 1, minus of 1 plus 1, 1 plus 1, correct. Now you can check it, this one, plus of, I can write 3 minus 1, minus of minus 3 minus 2, and the last one 1 plus 2, transpose of this. I will get this one 4 minus 5 1 1 0, this is minus 2, this is 2 5, this is 3, transpose of this, correct. I should write transpose of this. Only to find adjoint only takes time. I will write now adjoint A equal to, is writing transpose of this, 4 minus 5 1, first with first column, second with second column, 1 0 minus 2 2 5 3. I got adjoint A, right. Now I will simplify now. Because I can write, after finding adjoint I can write A inverse is equal to 1 by det A into adjoint A. So 1 by 10, we got 10 in the beginning, right. 1 by 10 into adjoint A. What is adjoint? You can write this 4 1 2 minus 5 0 5 1 minus 2 3. Now Ax is equal to B. X is equal to A inverse into B. So what is A inverse? 1 by 10, 4 1 2 minus 5 0 5 1 minus 2 3 into, what is B? We know B is 4 0 2, correct, 4 0 2. Again be careful, this is 3 by 3, this is 3 by 1, it gives 3 by 1. So 1 by 10, first with first column, 16 plus 0 plus 4, this one minus 20 plus 0 plus 10, correct, this one 4 plus 0 plus 6. So you will get this value. So you can see here 1 by 10 into, I can get 20, correct, this is minus 10 and this is 10. You will get 2 minus 1 1, 2 minus 1 1, you will get right 2, you will get 2 minus 1 1, 2 minus 1 1. Now you can write the values, therefore x y z, this is equal to, we got 2 minus 1 1. So x is equal to 2, y is equal to minus 1, z is equal to 1. Correct. You can verify whether satisfying or not. X is equal to 2 minus 2 plus 1, 3, 3 plus 1, 4. Definitely it should satisfy. So that will be the required answer. Now see, in this problem they are given A matrix. Find A inverse. Using A inverse, you should solve these three equations. To find A inverse, we want det A and adjoint A, right? Why? Because the formula we know that A inverse equal to 1 by det A into adjoint A, right? So det A you should find. When you are finding det A, so det A you can see here 2 into you will get minus 4 plus 4, minus of minus plus 3 into, leave this row in this column, minus 6 plus 4 plus 5 into, I can write this row in this column, 3 minus 2, that will come now, this will be a 0, right? Minus 6, this is plus 5, minus 1 not equal to 0, right? Now you should find adjoint. To find adjoint A, correct, you can use this transpose of this, right? I can use this, I can write nine determinants you can write, right? I can use 9 determinants. Now I can see here, this I can write plus minus plus, minus plus minus, plus minus plus, because minus multiplied with corresponding sign it will become cofactor. Leave this row in this column, you will get 2 minus 4, 1 minus 2. Cut this one. Leave this row and this row and this column. 3 minus 4, 3 minus 4, 1 minus 2. Leave this row and this column. 3, 2, 1, 1. Correct. Again come this row and this one. Minus 3, 5, 1 minus 2. And this one, leave this row and this 2, 5, 1 minus 2. 2, 5, 1 minus 2, and leave this row in this column, 2 minus 3, 1, 1, and coming to here, leave this row in this column, minus 3, 5, 2 minus 4, leave this row in this column, 2, 5, 3 minus 4, here, leave this row in this column, 2 minus 3, 2, 3, 2, now here I can write, this one I can simplify. This will be minus 4 plus 4. Alright, this one minus of, you will get minus 6 plus 4. Be careful when you are doing. Most of the people they will do mistake in adjoint only. When they are finding adjoint, most of them they will do mistake when they are finding adjoint of the given matrix. So minus of minus 6 plus 4, this one. I can write 3 minus 2. Now this one minus of 6 minus 5, here minus 4 minus 5, the minus of this one 2 plus 3, this one 12 minus 10, minus of minus 8 minus 15, this is 4 plus 9. Transpose of this, correct? We will get like this transpose of that. But at A minus 1 not equal to 0, we know that. So what I will do now, I will write now. After finding this is adjoint A, right? So I can write this one 0, right? Minus 6 plus minus 2, 2. We will get 1, 0, 2, 1. Minus 1, minus 9. And minus 5, 2, and 23, and 13, transpose of this. If I write transpose of this, you get 0, 2, 1, minus 1, minus 9, minus 5, 2, 23, 13. So we have, this is adjoint, right? Therefore, A inverse is equal to 1 by det A into adjoint A, right? This one we have. 1 by minus 1 into adjoint A, 0 minus 1 to 2 minus 9, 23, and 1 minus 5, 13. You multiply this, 0, 1 minus 2, minus 2, 9, minus 23, minus 1, 5, minus 13. So we have, this is A inverse, correct? Using A inverse, you should solve these three equations. Now what I will do now? So clearly we know that this is, you can see all the coefficients of x, y, z are this matrix only. A is given, this is A is given, I can write x is equal to x, y, z and b equal to 11 minus 5 minus 3. So use this A only, I can write Ax is equal to b implies x is equal to A inverse into b. When I have taken x is equal to A inverse into b, this is A inverse, right? I can write 0, 1, minus 2, minus 2, 9, minus 23, minus 1, 5, minus 13 into b, 11 minus 5 minus 13, right? I am going to simplify this. This is 3 by 3, 3 by 1, it gives 3 by 1. First with first column, 0, minus 5, plus 6, minus 22, minus 45 plus 69. This is minus 11, minus 25 plus 39. It comes 1, 2, that is 3. Therefore, I can conclude x is equal to 1, 2, 3. Want you can verify, if you want you can verify, substituting this, verify it gives 11. So this is the required answer 1, 2, 3. Now I will solve the next problem now. See, in this problem they are asking find the product of this, then use this product, you should solve these three equations. Now you can see here what is the benefit you will get this solve. This is easy, you can find. Why? Because if you multiply these two, take those two equations, you can multiply 1 minus 1 2, 0 2 minus 3, 3 minus 2 4, and this one minus 2 0 1, 9 2 minus 3, 6 1 minus. If you multiply these two, you can verify. First with first column, minus 2 minus 9 plus, you can see here, plus 12. This will be 0 and minus 2 plus 2. Again this one, 1 plus 3 minus 4. Again this one 0, right? 18 minus 18. Second with the second column, 0 plus 4 minus 3, 0 minus 6 plus 6. This one minus 6 minus 18, minus 6 minus 18 plus 24. This one 0 minus 4 plus 4, 3 plus 6 minus 8. You will get 1 0 0 0 1 0 0 0 1. When the product is equal to, this is identity matrix, right? When the product is equal to identity matrix, one is the inverse of the other. Here I can conclude that. Therefore, 1 minus 1 2, 0 2 minus 3, 3 minus 2 4 whole inverse is equal to, this one will get minus 2 0 1, 9 2 minus 3, 6 1 minus 2. When the product is called identity matrix, one is the inverse of the other. Inverse of this is equal to this I have taken. Why? Because you can take the coefficients of this x, y, z, this matrix. So inverse of this will, from this, inverse of this will be this matrix. I have written this. Now you will use this to find, to solve these three equations. Now you can see here. Now from these three equations I can write, this matrix I can write 1 minus 1 2, 0 2 minus, because there is no x, 0 2 minus 3. I can write 3 minus 2 4, x y z. This is equal to the given 1 1 2, correct? This one. If I take this side, it will become inverse, right? X y z, which is equal to inverse of this. 1 minus 1 2, 0 2 minus 3, 3 minus 2 for inverse of this into 1 1 2, right? If I take right that side, like this is equal to inverse of this into this. Inverse of this is this matrix, right? I can write minus 2 0 1, 9 2 minus 3, 6 1 minus 2 into 1 1 2. When multiply this, from that you can find the value of x, y, z. So you can write first with first column we will get minus 2 plus 0. Correct, we will get minus 2 plus 0 plus 2. This one 9 plus 2 minus 6. 6 plus 1 minus 4. 0 5 3. So x equal to 0, y is equal to 5, z is equal to 3. So these are three values. It's a simple problem, easily you can solve this problem. Now we'll do the next one. Now we'll solve this problem by using matrix method only. You should practice number of problems to get good score. Now you can see this one I can write. Let A is equal to matrix 1 minus 1 2, and I can write 3 4 minus 5 2 minus 1 3, and x is equal to x y z, and I can write B is equal to 7 minus 5 12. Correct? After writing this, I should find det A. Now after finding det A, I can write 1 into 12 minus 5, we will get minus 5, plus 1 into 9 plus 10, plus 2 into minus 3 minus 8. We count this one 7, this is 19, 22, it was 4, which is not equal to 0, right? After finding det A not equal to 0, A is non-singular matrix, find adjoint here, right? Why? Because A inverse is required. 1 by det A into adjoint here, right? Then I am trying to find adjoint A. When I am finding adjoint A, you can see here, adjoint A here. Remember the transpose. Now I am going to write cofactor matrix. I am going to write cofactor matrix. You see here I have written like this. First I will write here, you can see here. No, this one. First I will write minus, minor of 1, leave this row in this column. 4, minus 5, minus 1, 3. Minor of minus 1, leave this row in this column. 3 minus 5. 3 minus 5, 2, 3. And minor of 2, leave this row in this column. 3, 4, 2, minus 1. Coming to here. When I am trying to find minor again here, you can see here. I am trying to find minor of 3. Leave this row and this column. Minus 1, 2. Minus 1, 3. And for 4, leave this row and this column. 1, 2, 2, 3. And minor of minus 5, leave this row and this column. 1 minus 1, 2 minus 1. And coming to here, minor of 2, leave this row and this column. Minus 1, 2, 4 minus 5. And coming to here, so this is 4 minus 5. Now, leave this row and this column. 1, 2, 3 minus 5. Then as for leave this row and this column. 1 minus 1, 3, 4. You can see here I have written only minus. To make it cofactors, plus minus plus, alternative, minus plus minus, plus minus plus. Multiply this. Now it comes this one. 12 minus 5. 12 minus 5 minus of, this is 9 plus 10. Here minus 3 minus 8. This one minus of 3 minus 3 plus 2. This one 3 minus 4 3 minus 4. This one minus of minus 1 plus 2. Here you see this one, this one 5 minus 8. Here minus of minus 5 minus 6. This is going to write plus 4 plus 3. 4 plus 3. Transpose of this. Transpose of the right. Now, after writing this, I can write adjoint A matrix. I can write this is 7, write minus 19, minus 11, this is 1, and 3 minus 4 minus 1, this is also minus 1, right? Now this is minus 3, 11, and this is 7. Transpose, be careful transpose. Most of the people, they may forget about to write transpose. Should be careful. Write transpose of this. You will get 7 minus 19 minus 11, 1 minus 1 minus 1 minus 3 11 7. We got this one, right? Now we will solve the problem now. From the given equations, when I have written A, X and B, I can write Ax is equal to B implies X is equal to A inverse B. Now I can write X is equal to A inverse 1 by det A into adjoint A. This is adjoint A. 7 1 minus 3 minus 19 minus 1 11 minus 11 minus 1 7 into B. B value 7 minus 5 12. 1 by 4. You can multiply this. We will get 49 minus 5 plus 36. Correct. This will be 36. Next this one minus 133. This is plus 5. Plus you can see this one you will get 120. You will get 132. Correct. You will get this one. Next you can see this one minus 77 plus 5 plus 84. Then this x means x, y, z. 1 by 4 into, you can see 41, 8. This one you will get 4. Correct. This one you will get 84 and 12. Multiplied with 1 by 4. 2, 1, 3. X is equal to 2, y is equal to 1, z is equal to 3. After solving, you can also verify. Substitute the values, you can write 2 minus 1, 1, 1 plus 6, 7, it satisfies. Then this will be the problem, right? This is your final answer. Along with the previous 8 problems, you solve these 2 problems also. Then you will be thorough with matrix method. So these are in the given exercise, the last problem. We convert in terms of equations. This is an example problem. We convert it into equations. Try to solve these 2 problems. You will be thorough with this matrix method. I hope you will get 5 out of 5 in 5 marks questions if we solve all around 10 questions. Thank you. See you in the next video. For 4 marks questions, it takes only 15-20 minutes. That next video. Thank you. See you in the next video. Bye bye.